Ever looked up at the night sky and wondered, where did all that come from? Specifically, planets. It seems like such a simple question, right? But the answer is, well, it's pretty mind-boggling. So today, we're going to break down the cosmic recipe. We're going to show you step by step how you build a planet right from scratch. You know, it all starts in what looks like just empty space, that deep, dark void between the stars. But that darkness, it's totally deceiving. It's not empty at all. It's actually a huge, cold nursery, and it's filled with these massive clouds of gas and dust. These are the literal building blocks for every single star and planet in the universe. Okay, so you've got this giant, fuzzy cloud of stuff. How in the world do you get from that to an entire solar system with planets and orbits and everything? Well, it takes a whole lot of gravity, an incredible amount of time, and, get this, a surprising amount of chaos. Let's dive in. All right, first things first. Our story starts with one crucial step. We've got to turn that formless cloud into a structured, spinning disk. This is where the magic really begins. And the first thing you have to wrap your head around is just the scale we're talking about. It is huge. This all starts in what scientists call a molecular cloud. Just picture a gigantic, cold, dense patch of space that is hundreds of thousands of times bigger than our entire solar system. It's like our cosmic quarry. All the raw material is right there. So this cloud is just hanging out, right? But then, all it takes is a little push, a trigger. Maybe it's a shock wave from a nearby exploding star, a supernova. Something that causes a dense little pocket of this cloud to start collapsing in on itself, all thanks to its own gravity. And as it falls inward, it picks up speed. This whole first stage happens in what's, a blink of an eye in cosmic terms, just 10 to 100,000 years. Now, as all this stuff is rushing inward, something really cool happens. There's this rule in physics called the conservation of angular momentum. And what it means is, as the cloud gets smaller, it has to spin faster. Seriously, just think of a figure skater. When they pull their arms in, they spin way faster, right? It's the exact same principle. And that spinning motion is what flattens the whole cloud out into a disk, kind of like a chef spinning pizza dough. And what you're left with is this amazing two-part system. Right in the middle, where it's super hot and dense, a baby star, a protostar, starts to light up. And all around it, you've got this massive, spinning, flat cloud. We call that a protoplanetary disk. And that is the celestial construction site. It's the birthplace of planets. Okay, so we've got our disk. It's full of gas and dust. But how does that turn into something solid? Something you could actually, stand on? To figure that out, we have to zoom way in. Think microscopic. I love this analogy. Think of it like cosmic dust bunnies, but on a planetary scale. It really starts that small. Tiny, microscopic dust grains just bump into each other and stick. Over a long, long time, they grow into little pebbles, maybe a centimeter across. Then those pebbles start gathering together, forming kilometer-sized chunks we call planetesimals. And once they get that big, gravity finally takes over, pulling these planetesimals together to build up huge protoplanets. And that word planetesimal is super important here. It literally means tiny planet. These are the absolute key building blocks. Because once you get things this big, gravity can do all the heavy lifting. But, and this is a big but, getting to that stage, it's surprisingly tricky. And that right there brings us to one of the biggest puzzles in all of astrophysics. I mean, growing from dust to pebbles, okay, we can kind of see how that happens. But how do you get from pebbles to kilometer-wide mountains of rock floating in space? Here's the problem. See, once these things grow to be about a meter wide, they start running into trouble. There's all this gas in the disk, and it creates this sort of headwind that pushes on them. And that push should make them spiral right into the star in the middle, long before they can get any bigger. So, how do they survive? How do they bridge that gap? Well, right now, scientists have two main competing ideas. The first is called core accretion. Think of this as the bottom-up plan. You start small, with planetesimals slowly sticking together bit by bit until they form a core big enough to start grabbing gas. Then you have the other idea, gravitational instability. This is the top-down approach. Here, the whole disk itself is so massive, it just becomes unstable and collapses in on itself, forming giant planets directly and really, really fast. Honestly, the jury is still out on which one is the main way it happens. But here's the thing. Whichever way these planets form, they don't have all the time in the world. Nope. It's an absolutely frantic race against a very, very powerful clock. Sooner or later, that baby protostar in the middle is going to grow up. It's going to ignite and become a real star. And when it does, look out. It unleashes this incredibly powerful stellar wind. It's basically a cosmic leaf blower. And it just blasts all the leftover gas and dust, all your raw materials, right out of the solar system, forever. So yeah, you've got a deadline, a hard deadline. From the moment that cloud started to collapse, you have, at most, about 100 million years to build your entire solar system. After that, the construction site gets completely cleared out. The clock is definitely ticking. And that frantic building phase we talked about, going from dust all the way up to protoplanets, all of that has to happen in a window of just 3 to 50 million years. So well within that 100 million year limit. And you have to imagine this is a period of just insane creation and destruction. Constant collisions, things merging, things getting smashed apart, all of it shaping these brand new worlds. But if everything goes according to plan, after about 50 million years, the chaos starts to die down. The star is shining bright, all the leftover debris has been swept away, and what you're left with is a stable, mature solar system. Brand new planets are settling into their final, peaceful orbits. A whole new family of worlds has just been born. Okay, so that's the standard story. It's a really neat, beautiful model, right? But the universe loves to throw a curveball. And the things we're discovering out there in the cosmos, they are challenging everything we thought we knew about how this works. You have to remember, for hundreds of years, our own solar system was the only example we had. It was our only blueprint. But in just the last 30 years or so, we've found thousands of other planets orbiting other stars, exoplanets. And what they're showing us is just this stunning, sometimes completely bizarre variety of worlds that our neat little models, well, they just can't explain. I mean, for example, we're finding things called hot Jupiters. These are huge gas giants, bigger than our Jupiter, orbiting their stars in just a few days. That's way closer than Mercury is to our sun. Our theories say there's no way they could have formed there. We're seeing solar systems set up in ways that by all accounts should be totally unstable. And when we point our best telescopes at those protoplanetary disks far away, we see these weird gaps and spiral arms that hint at really complex stuff going on that we're just starting to understand. So what does this all mean? It means that our neat, tidy story of how to build a planet is, well, it's really just the first draft. Every new exoplanet we find is like adding a brand new chapter to the book. It's revealing that nature's ability to build worlds is so much more creative and, frankly, so much weirder than we ever imagined. It really makes you wonder, doesn't it? What other impossible worlds are out there, just waiting for us to find them?